All right. Hello, everyone. Good afternoon. Welcome to AWS, WAF Lessons Learned, how to use data-driven decision-making when all the bots are out to get you. My name is Mernaz, and I will be moderating this session. We have Phil today, who will introduce himself and start his presentation. Then we will have some time at the end for Q&A. So please put questions in the chat and I will read them out at the end. Please also note that we will be recording this presentation and an accessible video will be available for viewing hopefully next week. And with that, I pass it over to Phil.
Thanks, Renaz. Appreciate it. I'm going to share my screen here. As you said, my name is Phil. I'll get into here with, let's see here. Go. The slides up. Awesome. All right. So, as I said, my name is Phil Jacobson. I do work in the Division of Information Technology, and just as I read the description, just trying to cover some of the stuff about the web application firewall, and just how to deal with like being on the internet. If you folks haven't noticed, there are, of course, lots of things going on the internet, plenty of attacks happening all the time. As a visual, and this is almost ends up being one of the lessons learned here for later, being able to see this stuff happen in real time is actually very instructive for just about everybody, right? At all times, there are traffic of people trying to break into web servers, trying to add them to botnets, etc. The web application firewall from Amazon is just one of many layers that you could add to your application to try to protect yourself. As a team, we've had several learnings from this, and that's what I'm going to go over. So there's some aspects at the end I'll show with what does the thing actually look like? What parts are we using? But the lessons learned are almost more important than the specifics of the actual interface itself. So again, internet sometimes, if you think about it, not that great of a place to be, but there's all that. All right. So for today, we got 30 minutes. It's set aside to be 25 as presentation and 5 discussion. It's probably going to be less than that, so we can have some more time for questions. Again, I've been at the UW for over 18 years. I work with 2 services, the WhiskWeb service and the Do It Web hosting service. WhiskWeb having over 1,800 sites and shared hosting, the hosting service having over 600. We're going to talk about data-driven decision-making. What is that? Some of these lessons learned that I talked about that, and then a quick walkthrough at the end there. So data-driven decision-making, the idea is not just using your opinion or your intuition or the highest paid person's opinion in the room, but we're talking about trying to use data to further the mission. Do It sits, of course, inside the university, and there's part of our mission to Do It that has this thing about high quality, sustainable technologies and services. There are several layers before you get down to the WhiskWeb service, and each of these organizations interpret that part a little bit differently. In the case of WhiskWeb, we finally define it as things that we're doing with that about high quality, sustainable technologies and services, things that we can measure against page response time and number of errors, right? So if people visiting websites on WhiskWeb have quick page response times and they have very few errors when they go to these sites, that's a win. This diagram about the confidentiality, integrity, and availability, very common cybersecurity diagram. Confidentiality would have been like if we lost, actually lost data. The WhiskWeb service itself doesn't have any restricted data, so that's not the focus of this. And integrity, did someone get in and change something? It's also not the focus. We have a lot of ways to try to protect against that. But availability, that's if I've got too many bots showing up at one time and we're spending processing power, delivering responses back to them or even delivering them errors. That takes away from the real humans that are actually trying to get their work done and are trying to get some information from the websites that we host. So too many bots can cause us to have real humans getting a slowed experience or maybe even getting errors that are a result of the servers being overloaded. So that's really what we're talking about for today. Quite a few lessons learned. I'm not going to read all of these, but I am going to go through them one at a time. So first thing, know who we're dealing with here. Whisk Web Service runs on WordPress. It's a huge target, right? Over 43% of every website on the internet uses WordPress. So it's huge. It's very economical. It's the same reason why, when I started in IT a while ago, it was like this whole like, oh, there's so many bugs in Windows, and there's so many installations of Windows, so we're going to go ahead and attack those. It's like, it makes sense, right? Pick a really big target. There, of course, are millions of WordPress installations that aren't up to date. So there's that. When we receive traffic, we want to make decisions to stop talking to certain clients based on things, right? Some of it's self-identification. There's very few of these, but there are some scanners that, the name is something to the equivalent of, I'm trying to hack you. You're like, okay, I don't need to have any of those requests come into our system. Source IP address. There's going to be something we'll talk a little bit later about. Amazon has a thing called the known botnet data centers. It's basically a list of IP addresses of people who have in the past and continue to do so to provide lots of attacks. So that's something we can discriminate on. And then the most useful for us is behavior, right? So a normal human user using a web browser on a computer or on a phone, there's certain ways that's going to look, right? So what are they asking for? A normal human isn't going to have a SQL injection in the URL or in their cookies or the web page that they're asking for, and they're not going to be asking for thousands of requests per minute or per second, right? But bots do this stuff all the time, right? They're trying to figure out, hey, it's WordPress, which of hundreds of unpatched WordPress plugins, like, do you have any of them? So they're going to try all of it and just see if they can get in. But because it's really noisy like that, we can make decisions and just say, we're not going to talk to you anymore, or at least for a lockout period. For our team, this one was pretty huge, right? Visualization is understanding. I'll show you here in a second, but I've done over the years lots of looking at the raw weblogs, and they're very data dense. They are hard to read, hard to understand sometimes, and even stuff like this, where it's like, without doing some additional bit of analysis, you don't have good information about trend, right? Like, I can see this point in time, there was a request that had a SQL injection in it, but that doesn't tell me, all right, did that same IP address make requests like that, over the last week, month, minutes, or as it is a distributed denial of service where there's very few requests like that coming from repeatedly from IP addresses, but rather there's a trend of there's a whole bunch of them showing up from a variety of locations across the world at once. Again, just to visually see the text, here's a great example. This is a mod security audit log line. It's only partial, right? There's even more information than this, and it's hard to read. And a whole log file full of this stuff is hard to understand. I can't paste this into a report and send it off to our management and be like, hey, this is a problem, right? Like, this is very hard to wrap your head around what's going on here. In this case, of course, SQL injection they included some text in there that is considered SQL about, what is it, union found on, yep. So it's trying to do a union select all. So they're trying to get some information. But sometimes these graphs, these visualizations are spot on, right? Can you see where the traffic spike is? Right there in the middle, right? And it's very easy for our team to look at this and say, hey, so we've got this normal sawtooth pattern. This is what's expected, right? We've got Monday, Tuesday, Wednesday, Thursday, Friday. During the day, people are showing up and using those websites. Obviously, on a Monday here, somebody with some botnet somewhere decided to try to hit us with a whole bunch of traffic, right? That was a great decision. We do not need to talk to them anymore. That's just effort we don't need to expend. Here's another one. So this is one where we made a change to start blocking certain types of traffic. And very quickly, within a little bit of time, our team has this graph to be able to see, hey, this is like that change we made had an impact, right? This is like, a quarter to a third of requests at all times during the time here are being blocked now. Again, right? The team can very quickly identify, look at that. We made a change and it did something that we were hoping it would. So for all of this, it's not magic, right? There's this thing I was talking about, the known botnet data centers. It's based on Amazon's experience. Like, where are they seeing attacks from? either in the past or that they're getting right now. We don't get to see what that full list of IP addresses are, but we're, if you will, subscribe to the fact that they're going to keep maintaining that list, and that's going to continue to be useful going forward, that they're going to know stuff to add to it, and so it keep us as safe as we can, so we don't spend time processing requests from non-humans who are just trying to hack into our systems. This other part then too, like it requires effort, right? You had to be in a position to be able to use this thing. When the WISC web service started, we couldn't take advantage of this service if we wanted to, because SSL wasn't terminating at the load balancers. So, I'd done some presentations on this in the past, but we spent the better part of a year moving all the certificates into Amazon. Got some other awesome benefits in those other presentations about how, like, this search shepherd thing that Scott from our team and Jason from our team worked on as well. We get auto renewing certs. We don't have to do those manually. There's a lot of websites too, right? 1,800 plus. That would have been a lot of work had those not been auto renewing in the long term. But being able to read the traffic is what enables the web application firewall in Amazon to be able to see the whole request, like what cookies did you show up with, what other headers did you have, what other kind of requests did you have, so they can make a decision based on that. If you came in at the IP address from a known botnet data center, you can decide to block those right away. If they get classified as an SEO or a crawler or a scraper, whatever the thing is, they can make decisions and try to stop talking to them. As I pointed out with one of those graphs before, try to just change one thing at a time. It's going to be the easiest way for the whole team to understand, are we moving forward, right? This is a bit about that data-driven decision-making. We're trying to, can have a premise, let's have a hypothesis, let's test it, see if something gets better. We'll take anything that actually moves the needle in the right direction. Do we get things that reduce the number of attacks or reduce the number of impacts to service or page load time or those errors, right? There's an awesome thing from Microsoft Research a number of years ago where they had, it was broken down into thirds. So it was like 1/3 of the improvements are good. They make whatever you're working on better. 1/3 of the improvements you make have no statistical significant improvement or detriment to the service. And then 1/3 of them are actually worse. So out of all of, this is the brightest minds you have working on this, their best ideas, and when implemented, only 1/3 of the time with testing, you can prove that they were actually any better. There's going to be a link to that in the references, but that's a really awesome thing to keep in mind, because your salary or you being really smart doesn't determine whether or not it actually worked, right? You can't know that ahead of time. There's so many things here, so many factors. So make sure that you test have a premise, test it. If it's better, keep it, right? Keep the improvements that work. If it's not better, then set it aside. You learned something. We thought that was going to work. It didn't. Maybe I learned how to write some firewall rules better, something like that, right? If possible, try to use data to do the prioritization of what you're going to work on next. There's sometimes where that's not possible or that it's hard to do, but try to do one thing at a time. Give yourself a little bit of time to validate that it actually worked. It's really important. Otherwise, changing 6 variables at once, if you discover later that something happened while you changed those 6, you're not going to know which ones to roll back, and you're going to have to roll all of them back. So try to keep the ones that work. Go from there. Now this is a big one for our team too. To watch your costs, right? So on the surface, not that expensive. $5 a month for the ACLs, which you can put in a number of rules, right? So $1 a month for the rules. We have that managed ACL the bot control one from Amazon. That one's $10 a month. Totally worth the $10 a month for what we got out of it. But then we had a thing show up much bigger than what we were expecting. And so there was this hidden cost we had of transferring logs into CloudWatch. CloudWatch historically is the most expensive place to put your logs, but it wasn't even the storage. It was the cost of the network to get it into CloudWatch. That was the one that jumped on our thing. And I do have a graph for that. I'll show you that, folks, in a little bit. We learned though, hey, there's an option to put it into S3. S3 is inexpensive, and we don't end up incurring that same huge network cost. And then the last lesson learned here was just about, don't forget it's an arms race. We've got improvements that we need to continue to make, but there's improvements on the attacker side too, right? They keep finding, new ways to do botnets. They have them larger with more, more capacity to do things. And there's going to always be more 0 days. There's going to be more systems that are unpatched. So, keep your improvements. It's gonna be a continuous thing now. All right, let's take a look at some of the actual interface itself. Again, if you've got questions, make sure to get those in chat, and we can try to address those when we get a little bit near the end there. So for the WSWeb service, this is one of the ACLs in process, and I think this is, take a look at it, this is very close to what one of the graphs were that I showed before, which is that there's 2 lines that are near the top, which include, which are blocking. There's a certain amount of blocking that's occurring there. So some of that you get right out of the box. I'm going to jump over to the bot control. Again, this is the paid, that $10 a month one for that. And there's more information, right? Things that's already considering bots. And you can see that gets broken out between allowed and disallowed ones. And there's some of this classification or categorization that they're attempting to do, which on the surface maybe sounds worse than it is. And there are some examples of this, and I can give you this one here with the HTTP library, which is to say that this included all things, even command line tools that people have used for monitoring. If you make a wget request, if we were blocking all wget requests ever, it wouldn't work, right? It would get denied. But there's a few of these that we've gone through, and this is where some of that data-driven decision-making helps out, right? All of these could be suspect, or they could be benign. And we needed to have some good information. Let's look at the logs. Let's see what kind of stuff actually happens, right? In the case of some of these graphs, the most telling thing is like, all right, are one of these spiking really, really far up? Well, let's go take a look at that. And maybe the whole category is worth reviewing whether we should accept them or not. Or maybe it's just the one bot that was doing something very, very high speed or very request intensive. So that's the majority of what we end up getting from some of these visualizations. There is, of course, a lot to be done with the actual rules themselves. There's quite a bit of documentation. Let's see, that was the pricing, but yeah, right. So this is the pricing I was talking about. And there are various other rule sets that you can purchase as well from the marketplace. Yeah, managed rule sets. Again, as far as the WSWeb service is concerned, this is one of the first lines of defense that a bad request will run into. We have at least two other layers, depending on how you count it, that help do protection for this as well. But again, that sooner we can block a request that's bad, the better off we are, right? There's not a need again to process bot requests that aren't humans trying to visit a web page. Bots that are okay, and those are classified as such, are things like we want to make sure that Google can get in there and actually get the websites crawled so they end up in search results. Same thing for a couple of the other ones too, right? So Bing and Yahoo, etc. So those are all allowed in, and those aren't the ones that we ever have issues with. They're all reasonably well behaved, right? They aren't showing up and just destroying the server, trying to get every site completely up to date in 1 second. So there's a lot there. And that is most of what I had for today. We've got some of my reference links here, but let's see what we had in the chat. A couple of things. Yes, yeah. Jerry. Auto renewing certs. Yes. Yeah, 100%. I would almost pitch this over to Scott, one of our developers on the WSWeb team. We haven't implemented anything for the whole team to use with something like Athena. But that is going to be one of those things that's possibly on the radar. But yeah, Scott, if you are in the chat and want to respond at all to the exploration you've been doing with that, I'd say go for it.
Yeah, I'm here. I can speak if you want me to do that. I don't.
Yeah,
I don't
go for it.
Preference. I've looked a little bit into Athena and other log reading tools that AWS has offered. I've not really had the time to look into it too much as we've implemented this rather recently. But yeah, I mean, just using S3 for logs instead of CloudWatch really helped us with the billing department. So figuring out how to do that with the tools that they offer. Because one of the things that I saw with a lot of the stuff that they have for kind of analysis of log files is that you pay per data analyzed. Words are hard. So figuring out how to analyze the data without just like dumping in gigabytes of data is kind of the next hurdle. But that said, they do organize it in a way where a lot of it is saved in like 5-minute increments. So you can kind of go in and pick the time frame and just pick the log files from those times that you're kind of trying to look at and pinpoint stuff in.
Yeah, and as far as doing some improvements, you know, when a service impacting event occurs, we've got a really good idea of what time frame that happened at. And so being able to narrow down like, oh, I only need this 5-minute window or maybe these 2 5-minute windows. Even things like that are just help to try to eliminate noise and confusion. And likely isn't a thing that needs to be run at all times. And that's it's another fair point too. I will show see if I can find that one here again. The cost example. And this is, I showed a little bit of this in the other presentation, but we've got 2 lines here. The purple one was this thing called data transfer regional bytes. So it was costing somewhere between $10, $12, $13, something like that. After we turned on the WAF with the logging putting into CloudFront, we saw that came up quite a bit, right? So 23, I have 27, 24, 17, whatever. So the number is, and again, various ways to look at this, but that amount jumped enough, right? It's like doubled, tripled in some cases, depending on the day. And that was one where like, also we saw that, fall back down to what it was more normally once we decided to put the stuff in S3. So it took a little bit to dig into that, but overall we're like, hey, and we know we turned the service on and like, it had very reasonable cost information, right? Whereas, $5 a month for for a web ACL that has multiple rules, which are $1 a month each, but the costs we were seeing, weren't this amount, they were higher than that. And that's that's part of what we had. So any other questions?
I have a question. Go ahead.
Okay. I just had a question. I guess one thing that was going through my mind is kind of how helpful these services are, like, the web application firewall, to take care of all this stuff for us. I'm curious, trying to figure out how to put this. Like if, it's taking AWS Wave's taking care of like a lot of that underlying infrastructure. Do you find that there's things you need to focus on that are specific to your service? Like since AWS is taking care of more of the generic things, like is there anything maybe specific about, UW or WisWeb in general that kind of motivates maybe some more fine tuning? I don't know if that question makes sense.
I guess I'll try to answer a couple of things. So, and maybe I missed this in part of the overview too. So right now, WisWeb has 3 web application firewalls in play. This happens to be the first one that a request would run into. We also have mod security, which sits at the web server level, and we also have WordFence, which sits inside of WordPress, and has a lot of knowledge about what a WordPress attack looks like. Not every one of these layers talks to each other, nor do they share information. Like, WordFence knowing that something looked like a WordPress attack to XML RPC, for example, it's not, that information isn't shared up to those other layers. So there are things about this that, because for WisWeb we knew it's a WordPress install that we're configuring that makes sense. It's possible for us to add more rules that would say things like, if you ask for a request for, this location or that location, which wouldn't ever exist on a WordPress install, we may not need to talk to that address anymore, right? Or at least again for a lockout period. As far as maybe one of the things you're sort of getting to is like, do we just implicitly trust all of UW to make reasonable requests to the service? And the answer is no. We know instinctually, like, yes, traffic coming from campus or even just from Wisconsin alone is probably more trustworthy than just, a random location elsewhere on the internet. but we don't specifically have rules that say, yeah, you get a free pass, come in. Stuff that's definitely happened on campus though too is that people use crawlers in order to try to check their site for link checks, broken links, and other things, right? And those are legitimate use cases, but doing so in a manner that sends 100,000 requests to the server over the course of an hour is ridiculous and will not work, right? It's going to end up getting blocked by these rule sets. As far as the, kind of back to that lesson about the it's not magic, we turn this thing on and, well, nothing happened, right? That's the first thing. On doesn't mean configured. And so there's still a lot that had to be done in order to get useful stuff. If I recall correctly from the graph that I showed you that there was the block requests, I think that's when we turned on the known botnet data centers. And again, that's Amazon's definition, their maintained list of IPs that isn't shared with those other layers of web app firewall. I wouldn't suggest that this is a thing where you can just turn this on all your services and somehow everything's like magically better. It's not. And one of the advanced use cases, which we would need to do some work on, they've got some of these patterns where they're basically like, not only are you have some of this built-in functionality, but you do things like use either Athena or Lambdas or something like that to like take a look at the logs as they're coming through and to make decisions about adding things to block lists dynamically. Now, each web application firewall has an ability to do some of this on their own anyways, right? So mod security already has denial of service protections. There's certain things, if you've gone above that limit, you automatically get thrown in the timeout corner or whatever. WordFence has the same deal, right? You make too many bad requests or you make them too fast and you get set in a lockout thing. But yeah, none of them are magic. They don't, take all of the burden off of you. There's still a lot here to be done. The better you can define and you understand, first of all, what your valid customers are coming to visit, as well as what your service would ever respond to normally, the tighter you can lock it down, right? If you had a service that was an API service, maybe there is no concept of making an HTML request to, a request to an HTML page, like something.html. And, that's an example of like, well, then maybe you don't ever talk to anybody who asks for that because that doesn't even make sense. In our case, again, there's things that are WordPress specific that like, if you ask for like a thing that's a, PHP my admin, like there is no PHP my admin. There never will be. It's WordPress. There aren't any Drupal pages. Like there never will be. It's WordPress. So I don't know if that helps or if that confused anything or if you've got something more specific, Jared.
No, yeah, that was helpful. Thanks for talking through that. It was interesting to kind of hear about some of the challenges you ran into with like UW sources and like the crawlers and how you dealt with that. So yeah, thanks for explaining that.
Yeah, other fun fact about UW stuff too is that being on VPN is incredibly useful. But because WhiskWeb sits on non-campus IP space, we see, of course, all of those as as external. They're external requests. So a lot of VPN people who are connected to VPN come out just a handful of IP addresses to the internet, and so that's been another interesting thing to deal with. Even on campus, some of that aggregation is it's network address translation. You pile a bunch of stuff into a single outbound IP address, and had that actually been a human, it doesn't make sense. Knowing things like, well, those are the ranges that UW uses to aggregate for NAT traffic outbound to the internet. That helps a lot. It's not perfect because you need to try to make exceptions for that if you can, or set the limits a little higher. I don't know.
Okay.
Other questions?
Any other questions? We're almost at the time. It was a great session. Thank you very much, Phil. And thanks everyone for attending, asking questions and stuff. There are still a couple or more sessions going on, so make sure to check them out. Other than that, have a great rest of the day. Thank you.
Thanks, folks.